Hi everybody, this is section 3.2, still, solving systems of equations by yet another method called elimination. This is homework number 43, slides 22 through 27. Okay, so most of this I just want you to pay attention to, watch, and see if you understand it. Okay, so when we use the elimination method, what we want to do is to try to multiply one or both of the equations by a number if needed. And the reason we want to do that is because when we add the equations, okay, we're going to add the equations together, we want either the x term or the y term to drop out. In other words, then we want them to add up to 0. Because if they add to 0, then you can then you have one equation with one variable, as you see right here. We can solve that for x. If you have two equations with two variables, as we do right here, you can't solve it. So that's what we're doing here. Okay, so this is an example of what I mean by multiplying by a number. So look at these two equations right here. You'll notice that we have y and 2y. And if we were to add these two together, we'll get 3y. Let's just say we're going to add these two equations together. We get 3y. And that doesn't help us because we don't get rid of anything. But if we could change this so that this were negative 2y, then when we added them, negative 2y plus 2y would give us 0y, and then the y's are gone. So that's what we're going to do. So we are going to multiply both sides of the equation by negative 2. And a common mistake here is to not multiply both sides by negative 2. So you'll notice here we have 2 times y is negative 2 times y is negative 2y. Okay, so I'm multiplying by negative 2 right here. Negative 2 times 3x right here times 3x is negative 6x. That's where that comes from. And then negative 2 times 5. So we're multiplying by negative 2 by every single term. So negative 2 times 5 is negative 10, and that's where we get that equation. Now, the second equation didn't change, right here. But now when we add them, negative 2y and 2y is 0. Negative 6x plus 4x is negative 2x. And negative 10 plus negative 7 is negative 17. Be really careful with your variables on this stuff. So from here, we can solve this equation. We know that we would get x equals 17 halves. And then we can substitute this x back into one of the beginning equations. So we'll see how that works here in a minute. Okay, now let's start from the beginning and see how this works. This should have a bracket in front of it. So we have two equations. I'm calling them Q and W. Okay, so Q is here and W is here. So these two equations, you'll notice if we add these two equations, when we add the x's, we're going to get 0, and that's good. That's what we want. So we don't have to do anything to these two equations. Now, your question might be, how come we're allowed to do this? Well, you'll remember that if A equals B, then we're allowed to add the same thing to both sides of an equation and keep the equality. That's called the addition property of equality. So in this particular case, if you think of the x and the y as the A here, and the 5 as the B here, to start with, we know x plus y equals 5 from our equation Q. Then if you look at equation W, then negative x plus y, this thing right here, and 9 are equal to each other. And therefore, because they're equal to each other, we can add negative x plus y to the left side of equation Q and 9 to the right side. That's essentially adding c to both sides of the equation. And adding c to both sides of the equation doesn't mean you have to add the exact same thing to both sides. It means you have to add equals, which is what we did. We added negative x plus y to one side and 9 to the other side. And we know those two are equal because equation W tells you. Now you might want to stop this and rewind a little bit and watch it again. So this is the idea, this is the why of how come we can add these equations together. So back to our two original equations, you can think of this as column addition. So what we're doing is we're adding the columns together. So this column, and this column, and this column. So x plus negative x is 0x. Y plus y is 2y. Remember, a y by itself means 1y, right? That's why we get 2y. And then 5 plus 9 is 14. So now we have one equation because there are no x's left. So now we have 2y equals 14, right? One equation in one variable. That's always our goal when we use the elimination method. Why is it called elimination? Because we eliminated the x variable when we did this process. Okay? So now we have to find out what, finish this by finding out what y is. Okay, so from that last slide we have 2y equals 14 right here. And so we divide both sides by 2, as you know, and we get y equals 7. So now we know what y is for this system of equations. Now remember that what's going on here is that we have two equations that if we graph them, they're going to cross somewhere. Okay, so I don't know exactly where these lines are, but if I look at them carefully, I do know that one of them slopes upward and one of them slopes downward. Hold on, I gotta try that again. So one of them slopes upward and has a y-intercept of 9. You don't normally have to do this. I'm just doing this to show you what it is we're doing here, okay? And one of them slopes downward, and somewhere they intersect, right? That's the point we're looking for. And what we just found out is the y value for that point is 7, okay? Now we need to figure out what the x value of that point is. What is this point right here? That's what next thing we're trying to find. So we substitute, because we know that y equals 7 from right here, we substitute 7 into equation Q. Remember that was one of our original equations. Now it doesn't matter which equation you substitute into. Either one will work. So pick the easiest one. So here I have x plus y equals 5. That was the original equation for Q. And then I put the 7 in because I know now that y equals 7. I solve it by subtracting 7 from both sides, and I get x equals negative 2. What that tells me is that this point right here must be negative 2. Okay, and we have our solution to our equation, which is negative 2, 7. So we have negative 2, 7, and that's where the graphs intersect. So to check this, we have to substitute our equations in, our solutions in both of the original equations, and it has to work. So here I have negative 2x plus 7 is supposed to equal to 5. So negative 2x plus 7 is 5, which is equal to 5. It checks. Over here, this is the way we check sometimes, drawing a little table like this. So this is the opposite of x. So it's the opposite of negative 2 plus my y, which is 7. Which means 2 plus 7, which is 9, which is equal to 9. it checks. Okay, so we know our solution is correct. Now let me just say, you always want to substitute into the original equations. If you don't, you run the risk that you made a mistake